All right, this is a great question. I love this predicting boiling point type of questions because it's really making you think about, okay, first, what is an intermolecular force? What are the options for intermolecular forces? And then how can we predict these based on both the size of the molecule, the intermolecular forces it has, and then not only that, but we're comparing them. So we're not actually picking a boiling point, which we could do, and we did in class when you have some information that shows some close boiling points, but we're going to rank them based on what we think and how they compare to each other. Okay, so let's take a look. We got F2 here, which is just F bonded to itself. It would look like that. If you did the Lewis structure, it would look like this. So not polar, covalently bonded. And then we got its molecular weight, which is about 38, 19 times 2. Now we got a organic molecule. Here we got 2 carbons, 2 oxygens. So we have some polarity here, carbon pulling the oxygen. We have polarity here, and we also have hydrogen bonding. So we have dipole plus H bonding, and then we have a mass of 58 roughly. Here we have a little smaller molecule. Again, we have some polarity, lots of polarity coming this way, same thing here. But no hydrogen bonding. So there's no hydrogen, there are hydrogens, but there's nothing coming off the oxygen or the fluorine. So we have just a dipole here, and we have a molar mass of 62 maybe. Just doing these quickly in my head here. Now I do have to scroll down. Last one, again, we have a dipole, but we only have 12, 15 plus 19, so 34. So I'm going to say, now let's look at the question. Choose 1 to the substance with the highest boiling point, and then 2 with the next highest. So I'm going to say B here has the highest boiling point because it's the largest and it has hydrogen bonding, which, like water, right? Water is this very small molecule, but because of its dipole and its hydrogen bonding, it has a relatively high boiling point compared to anything else with that mass. So this one's going to be 1. 2 would be, I'm going to say this one because it's got a high mass and a dipole. 3 would be here due to the dipole, and then 4 would be here because there's no dipole and has similar mass to D. So we got 38 compared to 34, a little higher up here, but no dipole. So let's check that. There we go. So maybe draw some quick structures, add up some molar masses, compare those molar masses. Remember, if the bonding is the same, so they both have dispersion or they're both dipole, molar mass comes into play. If the molar mass is similar, then the type of intermolecular force is really important. And it can get tricky if you have something that's really high molar mass with just dispersion versus like something with dipole that's a lower molar mass. That molar mass can start to outweigh the intermolecular force. So those ones can be a little bit trickier.